Unit 6, Section 3, rectangles. All right. Properties of rectangles. A rectangle is a parallelogram. So all of the things that we learned before, opposite sides are parallel and congruent. Opposite angles are congruent. Diagonals bisect each other. All of that applies because these are parallelograms. But there are more specific kind of parallelograms. So like if sports is the biggest label, and then we say football is a label underneath sports, we're at parallelograms, like quadrilaterals is the sport, parallelograms is football, rectangles is the Buccaneers, right? So, and then squares is Tom Brady. He's a person on that team. So let's look at rectangles. Opposite sides are congruent. Opposite sides are parallel. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. And all four angles are right angles, 90 degrees, and the diagonals are congruent. Their measure equals each other. So we've got all of the rules that we did before plus two more. The corners are all 90 degrees, and the diagonals are congruent. Okay. Each quadrilateral below is a rectangle. Keep that in mind for the rest of this thing. Find the missing measures. So, we know that all the corners are 90 degrees, but this isn't even asking about corners. This is asking about sides. Well, this side is 24, and this side is 10. Okay. So, QR we know is 10. SR is 24. S to Q, we don't know yet. PR, we don't know yet. QT, we don't know yet. So how can we figure those out? Well, you might have been shown something in algebra. You should have been shown something in algebra that would allow us to figure this out. And that is something that deals with triangles. And maybe you remember that a squared plus b squared equals c squared. So if you have a triangle that is a right triangle, side A, side B, and side C, the square number of A and the square number of B added together should equal the square number of C. So SQ is going to equal 10 squared plus 24 squared, okay, equals x squared. We got to solve for x. Well, 10 squared is 100. Let's look at what 24 squared is. 24 squared is 576. And so that's 676. And so 676, we want the square root button. 676, boink. So x equals 26. Very nice. So S to Q all the way across, because we had side 10 and side 24. Now we know all the way across is 26. That means that this piece is 13, and this piece is 13, and this piece is 13, and this piece is 13. So SQ is 26. PR, they're congruent, so it's 26 as well. QT is half bisected, so that'd be 13. We're going to be using that a squared plus b squared equals c squared thing. We'll throw x in there. Variables are variables. It doesn't matter where you put them. It's the unknown. Right, so in our thing, A was 10, and B was 24, and C was X. So we just keep rolling that around to places that we don't know. So if you'd like, go ahead, pause, give number 2 a try. Here we go. I know this one's 27. I know this one's 15, and that one's 15, and that one's 15. What I don't know is 80 and BC. But if I know the whole way, draw a little triangle over here to the side. That's 90. I know the whole way is 30, and I know this one's 27, and I don't know that one. I know 27 squared plus x squared equals 30 squared. So what is 27 squared? 729 plus x squared equals 30 squared. Should be 900 because 3 times 3 is 9 and 2 zeros. Minus 729. X squared equals 171. Let's do the square rootiness. Square root of 171. Okay. So here's where we're going to have to get into the realm of almost, because we're not going to write decimals for the rest of our lives. Okay. So x is approximately 13.1. And we're just going to consider that that's 13.1 because we have to, right? So let's plug these in. A to C all the way across was 30. B to D all the way across was 30. B to E, the middle, was 15. A to B is 27, matches the bottom. And BC, we figured out, is about 13.1. It'd be better if it was like squiggly. Okay. Number 3, let's talk angles. Okay. We know that that one's 27, which means we know that this one, it's not a 7. This one's 27. We know the whole corner is 90, so if I take 90 and I subtract 20, that's not a 20. 27, boink. I know that this one's 63 degrees. So I know this one's 63 degrees. Boom, boom, boom. So I know some of these angle pieces. So that's doing me some good there. Very nice. So let's look at the whole thingy here. Let's see. MJK. M to J to K. Well, that's easy. That's 90 because all the corners are 90. M to J to L. That one was 63, we figured out. J to L to K. That is also 63 degrees. K to M to L. Well, how could we figure that out? Well, let's have a look. What do we know about the insides, right? They're all the same. That means that that triangle is isosceles. If the sides are the same, then the angles are the same. So that one's got to be 27 degrees. And then lastly, they want M in L. They want that inside angle. Well, it's 180 minus 27 minus 27. That's 126. See, we have to end up thinking about ways we can use the information that we have in order to solve what is necessary. So don't forget all of those things we've learned. Isosceles triangles have sides that are the same, which means their base angles are the same. Equilateral triangles, all 60 degrees, all the sides are the same. All the sides are the same, all the degrees are 60. Not only the same, but 60. Okay, go ahead, try number 4. Let's see what you can come up with. All right, well, we know this is 64. And we know that 180 minus 64, this is 116. Those are 116s. Now, if we take 180 and we minus 64, that's 116. We know that part. Now, if we divide it by 2, okay, these have to be 58. And that means that these have to be 32s. Mr. Maggie, how do you know they're 32s? Well, the supplement of 116 is 64, and half of that is 32. And I know that the bases match because the diagonals bisect and are congruent. So that means they're isosceles triangles. So boom. So x, w, y. X to w to y is 58 degrees. Y to x to z is 32 degrees. W to v to z was 116 degrees. X to w to z, that's 90. And x to z to y is also 58 degrees. And that's how it works. Given dB equals 42, so that's 21 and 21. And we know then that's 21, and that's 21. 80 is 26. And the measure of angle DAE is 52. DAE is 52, so that's 52 degrees, which means that's going to be 52 degrees, and that's going to be 52 degrees. And we can figure out the rest of that. See, 90 minus 52 is 38. And so 38, say 180 minus 38 minus 38 is 104. And 180 minus 104, that's supposed to be 80 minus 104 is 76. Okay, I got everybody. So, whoop, that's not what I wanted. There we go. I want you to go away. There we go. A to C is 42. E to B is 21. B to C is 26. A to B. Oh, I don't know that one yet. But I know that, let's see, if I draw me a little triangle there, this is A to B. That one's 90. This is 26. That's 42. This is X. So X squared plus 26 squared equals 42 squared. That's a degree symbol. Squared. X squared. 26 squared. Plus 676 equals 42 squared. 1764 minus 676. X squared equals. And then we're going to 1088. Square root both sides. So square root of 1088. Enter. Oh, okay. Alpha y equals fraction to decimal 32.98. Or we'll say about 33. Let's see, x is about 33.0. Now I put the 0.0 on there because when we rounded before, we rounded to the tenths. This time we rounded tenths, and the 8 makes the 9 turn into a 10. I don't leave it off because I significantly rounded to the 10 spot, so that spot is important. I know that I'm rounded to 0.0, so I leave it there. So I'm going to say about 33.0. Now, the answer key may just say 33, but technically it should be 33.0. A to D to C. Well, that's easy. That's 90. A to B to D. Well, that was 38. B to C to A. That's 52. And D to E to C. That was 104. If you go ahead and figure out everything on the whole figure, it's a lot easier to plug in the answers as you go. Now it's algebra. Find EF. Well, remember you need EF equals, fill in the blank. Don't just find X. Opposite sides are congruent. So 7x minus 39 equals 3x plus 5 minus 3x. 4x minus 39 equals, that's a 9, I promise, equals 5. Add 39. 4x equals 44. Divide by 4. X equals 11. I don't need to know what x is. I need to know what EF is. So 3 times 11 plus 5. 33 plus 5. 38. That's the part I need to know. It's supposed to be 38. Go ahead and give it a pause. You try. If RT all the way down is 5x minus 14, and US all the way across. So the diagonals are congruent. These are diagonals. So I can say 5x minus 14 equals 2x plus 10. I need to find VT. Remember that. I need a piece of it. I need 1/2. So I need x. I need to plug it in. I need to cut it in half. All right. Wow. Minus 2x. 3x minus 14 equals 10. Add 14. 3x equals 24. Divide by 3. X equals 8. Don't need x. Need bt. Let's plug it in. I'm going to go 2 times 8 plus 10 because times 2 and plus 10ing, super easy. 16 plus 10 is 26. That's all the way across. That's u to s or r to t. So we need half of that, which is 13. Let's look at number 8. If Jm is x plus 17 and mk is 5x minus 23, find JL all the way across. So we need to plug it in and double it this time. So we need JL equals what? Find x, plug it in, and then double it because JL is all the way across. And these are bisectors. Okay. Now, we know that they're congruent because diagonals are congruent and they bisect each other, so their pieces are congruent. So I know that 5x minus 23 is equal to x plus 17 minus x. 4x minus 23 equals 17. Add 23. 4x equals 40. Divide by 4. X equals 10. Once I know that x equals 10, I can plug it in. 10 plus 17 is 27 times 2. 2 20s is 40. 2 7s is 14. So that's a total of 54. This time we're finding WT. So get x and find WT. I'll help you label it here. If VW is 9x minus 11 and SU all the way across, is 16x minus 12, then what could you do to find? Okay, they're saying the whole way. Well, we could say that 9x minus 11, because those are congruent. And so you got 9x minus 11 and 9x minus 11, or 2 times 9x minus 11 equals 16x minus 12. Or you could cut them in half and say that 8x minus 6, 8x minus 6. Well, where'd you get those? Well, they bisect. So if I cut that in half and I cut that in half, half of 16 is 8, half of 12 is 6. Okay, and I can do them like that. And then I could say 9x minus 11 equals 8x minus 6. Or I could say 18x minus 22 is equal to 16x minus 12. Either way works. You can see it whatever way you want to, but know that one part was half and one part was double. That's all you got to do. So I'll do 9x minus 11 equals 8x minus 6 minus 8x. X minus 11 equals negative 6. Add 11. X equals 5. And then all we have to do is plug it in. We need W to T. W to T is 9x minus 11. So 9 times 5 minus 11. 45 minus 11. 34. Four more. Let's give them a go. Oh, these are all angle stuff. So the last ones were all sidey stuff. This is all angly stuff. So find the measure of BCE. Measure BCE equals some amount. We're going to have to find x and then plug it in. Now, this is a parallel line. This is a parallel line. This is a transversal. These are alternate interior angles. They are congruent. So 11x minus 3 is equal to 7x plus 5 minus 7x. 4x minus 3 equals 5. Add 3. 4x equals 8. Divide by 4. X equals 2. 7 times, right, where's BCE? BCE. Ooh, so we just need to know what that number is. So 7 times 2 plus 5. 14 plus 5 is 19. If this is 19 degrees, let's do 90. 90 minus 19 Makes that 71, because that's 19. So we got 71 degrees. All right. Find the measure of angle JHI. On your mark, get set, go. Pause, of course. Let's try it. Well, we know that that corner is a box, which means that 3x plus 2 plus 12x minus 17 is equal to 90 degrees. So that's 14x minus 15 equals 90. Let's add 15. 14x equals 105. 105 divided by 14. Ooh, that's weird. Did we get a fraction on that one? Or did I do that the wrong way? Oh, hey, look at that. 3 plus 12 is not 14, it's 15. And then we do 105 divided by 15. That's supposed to be a 5. 105. Fart. Narfin. 105 divided by 15. Boom. 7. There we go. X is 7. What are we supposed to find? The measure of angle JHI. Let's see. JHI. That's this one. It's the same as that one. So let's plug it into the 3 plus 2 is 21 plus 2. So it's 23 degrees. Just like that. Measure of angle XZW. Let's see, where's X? XZW. This is the one in question. What does it equal? Well, if we knew X, we could take 90, subtract it, and do that. So, let's see. This one is congruent to that one. So that's a 5x minus 8. So 5x minus 8 plus x plus 20 should equal 90 degrees. 6x plus 12 equals 90 degrees minus 12. 6x equals, drop it down, let me see, 78 divided by 6. Let's see, 78 divided by 6. 13 times. We don't need x, we need to plug it in. 13 plus 20 makes 33 degrees. Oh, we didn't need that side. We needed the other side. Go back. Which side do I need? I need the one that's 5x. Okay, so 5. That was weird. 5 times 13 minus 8. 5 times 13. That is weird. That is also weird. 5 times 13. 65 minus 8. Might as well. We're in the calculator. 57. That's better. Didn't look like 33 degrees, but what do you know? Last one. Give it a try on your own. Come back. Let's see how you do. All right, here we go. Solve for x. Oh, man, all we got to do is make x happen. Love it. Well, let's see what we can know. We know not a lot. Well, we could do this. 180 minus 134. That's 131. 180 minus 134. We know that this is 46 degrees. And 180 minus 46 degrees is 134 degrees. That makes sense because we just found that. So these, oh yeah, remember that thing. Oh yeah. The exterior angle, so this guy out here, the exterior angle is equal to the sum of the non-adjacent angles. Now, since this is going to be equal to that, we also know that this is 5x plus 7. And so we know 5x plus 7 plus 5x plus 7 equals 134. This one and that one. Notice how they're the same. We could have said 2 times 5x plus 7 equals 134 because we have two 5x plus 7s. So now I'm just going to divide by 2. 5x plus 7 equals 134 divided by 2. 67 minus 7. 5x equals 60 divided by 5. X equals 12. Now, you could have done that a total different way. You could have, instead of saying that it's equal to the exterior angle, you could have said, well, 5x plus 7 and 5x plus 7 plus 46 equals 180, and solved it that way for the total angles in a triangle. Okay, there's multiple ways to solve these problems a lot of the time. But as long as you follow the math, you'll always get to the same result at the end. I care about your journey, not about the end. Don't just write the answer down. Know how to get there. Okay? A couple of different plans. But that's what we got for rectangles.